channel to the device. Now, because of the mobility, the device or IoT nodes move from one location to the another location. So the single carrier will not be make this communication uninterrupted. So we have to go for opportunistic access. I mean, in the change of zone from one zone to another zone, it would be communication should keep on continuing uninterruptedly, and that is an again issue of seamless connectivity. So seamless connectivity, not only the communication channel to provide, but also it should be uninterrupted. Then IoT would do lots of intelligent and automated tasks. So here would be interaction with the data from the clouds, and you need to dump these results to the cloud. So that again needs a communication path. That needs by communication path, I like to say the communication channel. Power limitation is the devices. Either you have to go for an energy harvesting, or you have to frequently deploy the battery, change the battery, or nodes you have to deploy in any application. So what is that? Demands is, as the IoT devices are tiny devices, power limited, we can go for passive communications. Now understand, in traditional communication, in our class communications, when we teach, we see that radio wave communication or carrier communication, amplitude modulated, frequency modulation, or in ASK, FSK, PSK, different types of, there are radio waves, the high frequency, which plays the role of carrier. And that is the main concern of power consumption. In any traditional communication, RF circuits, amplifier, oscillator, the converters, these are the culprit for power. They are power hungry more. So, in any active mode of communication, where you have to make use of the radio wave for long distance communication through wireless channel, there are the issues of power. But if we make use of the traditional active communication for IoT devices, then these power hungry components you cannot avoid, which will limit the span of the lifetime of the IoT devices. So we need to go for an alternative arrangement. Alternative arrangement is the passive communication. Let us take an example. You can see the some people do. The some people do like in sense that what the vehicle. When you can see that in the road, some bike or some cars are going, some people take looks for a trip or like that. So it is something like the carrier. If you consider the bike as a carrier, there was a primary rider, I mean the traveler who was going, and there are vacant spaces. A secondary, or if I mean the passerby likes to avail that facility, and it is a kind of win-win game. In win-win in the sense the sawari and the back end who is availing the facility can guide. Okay, there is traffic, there are cars. You go like this way, or sort of thing. So it's a kind of mutual win-win game. What I'm going to say, the existing transport phenomenon, transportation facility somebody is availing. So the standing passerby or the travelers is a passive users, and the active users of the traveler which was having the own bike, and this way it's a kind of, so in that sense a passive kind of transportation. In communication we are also considering a kind of communication that's called passive communication. IoT could have a passive communication. The passive communication means that there are smart homes, there are smart cities, large number of sensors are collecting data, and that data needs to transmit. Now, these smart devices cannot have this own facility of RF circuits or RF carriers because it's a power hungry. It will limit the lifespan of these devices. What it can do, the sensor data or sense data, the captured data, sensor can write this in the existing communication signal, primary communication signal. What is that? Now, Wi-Fi signals, the cellular communication carrier, the existing RF signals. The so smart sensor will put that data onto the carrier's existing carrier communication. So this is basically called as a symbiotic. I'll be talking in the context of later. So this is basically a backscattered communication and leads to the concept of symbiotic radio. My talk on backscattered communication and symbiotic communication to be in the second part. I mean the post-lunch session. Now I'm back to the cognitive radio concept here, because in the context of symbiotic radio or RIS, my whole talk on RIS in the perspective of cognitive radio. So I will be talking about here the cognitive radio. I say at one point of time that you can see that 1 to 10 gigahertz is heavily occupied for the existing communication, like WiMAX, Wi-Fi, 3GPP, and all these. So if you can see that your medium wave communication, radio broadcasting, FM, skywave, and all these. So lower part of the frequency spectrums are heavily congested for different types of already existing communication services. Now, there are IoT communication needs. So you need spectrum. How this can be done? Now, the existing spectrum allocation is called static mode of allocation. Static mode of allocation means if you see that 88 megahertz to 108 megahertz is for television communication, FM communication. Now you can see that how many FM stations are there in the northeast part of our country, say for example in the it may be the metro city like Kolkata, Delhi, Mumbai, there are a large number of stations. So a whole range of frequency, there are different channels. But if you think about the the city like Agartala or other city in the Guwahati and all, you don't expect that there may be that many number of FM channels. So 88 to 108 megahertz, this frequency which are allocated for television, regional television broadcasting and FM, they are underutilized, or in other sense, the frequency are underutilized. How one know it? Now there are regulatory bodies, FCC or ICC. So that regulatory bodies who allocate frequency for in every country, there are frequency regulatory bodies who assign what frequency to be used for what particular communication purpose. So FCC, CCITT, those regulatory bodies, when they observe that 85% of the allocated spectrum due to static mode of allocation. By static mode means for this particular communication, this frequency. So this is static mode of allocation and spectrums are underutilized. So why don't we go for opportunistic communication? So the situation is what? That there are license users. These license users are allocated with a particular frequency, but these license users are not enough data to transmit for all the time. So spectrums are underutilized. Now, a secondary users for its IoT communications, they like to access spectrum of the primary user. So what a secondary users or IoT device as a cognitive device can do, like the cognition ability, like the cognitions, I hope you know. So in context of radio, the radio environment will be sensed by a secondary transmitter or a IoT device. A IoT device will sense the radio frequency spectrum and observe that whether primary user is using this spectrum for communication purposes of its own communication purposes or not. So if it finds that the primary is not using that one, then secondary will go for transmission. Many of you, when you study the computer networks, you know CSMA, carrier sense multiple. A bus topology, multiple users are sensing the carriers whether coming and collisions is there. So something like that way, a primary user or a licensed users allocated with certain frequency, the secondary users just before its own data transmission sense whether radio frequency of assigned to the primary user is currently being used or not. If not used, then secondary opportunistically go for transmission. But there is a chance of collision because primary may start communication. So secondary has to control power. Secondary has to remove its communication or take out its communication, stop its communication. Or if it continues by any means, it has to control its power so that interfering effect for the secondary users to the primary user receiver will not be be above the threshold or above the permissible limit. That means what I am going to say. Often in the classroom, when we deliver lectures, our students talks among themselves. As long as these communication levels of the power below the interfering limits permissible to us, the communication can be going on. We can take our classes. So that is a kind of communication, called cognitive radio communication. So in one hand, due to the static mode of allocation to the primary users, it's the scarcity of the radio frequency spectrum. In other cases, there is efficient utilization of the spectrum by means of opportunistic communication. And this is called cognitive radio network. The terminology first proposed by Joseph Mitola in 1990. What is cognitive radio communication says? That it's an intelligent and opportunistic communication where a secondary users opportunistically avails the primary user's communication spectrum by means of sensing. That means before data transmission, it just sends whether primary is transmitting or not. And based on the available, say maybe the primary user is not communicating, but not on its whole spectrum, a part of the spectrum it is. So available spectrum to the secondary users may be variable. So accordingly, it change its data transmission rates to reconfigure its communication. So cognitive radio is concept which is automatically detects the available channels, flexibly changes data transmission rate and receiving parameter to make the efficient mode communication. So there are two things. One is the cognitive capability and reconfigurability. By cognitive capability means it can sense whether primary spectrum is free or not. Reconfigurable based on the available spectrum. It changes its data transmission rate. It changes its transmitting and receiving parameters. Right? So in cognitive radio, there are two or three party gains in that sense. One is the primary user, who are licensed user, who are having the fixed spectrum. Secondary user is an opportunity